Hi, in this video, I will be showing problem number 25 of chapter 11, section 3. Determine whether the series is convergent or divergent. The given series is sigma n varying from 1 through infinity 3 over n square plus n cube. Now we will apply the partial fraction for 3 over n squared plus n cube. So 3 over n square plus n cube can be written as 3 over. If you factor the n square out, it's n square times 1 plus n. So which is product of linear factors, linear factor and a quadratic factor in the denominator. So we can write that as 1 for each linear factor in the denominator, a over n, b over n square plus c over n plus 1. Then we have an equality here, 3 equal to, if you take the LCD for this right hand side as n square times n plus 1, you can write this as 3, the left hand side, equal to a times n times n plus 1, b times n plus 1, plus c times n square. So this is what you will end up with by taking the LCD of n square times n plus 1. So let's call this as equation 1, and then we have to determine what the constants a, b and c are. If you recollect the method of partial fractions, all we need to do is to plug in values for n, because this is kind of an identity, so this is true for all values of n. So we will start off with the easy value, substitute n equal to 0 in this relation. So we get 3 equal to a times 0, so the first part is 0. The second part, b times 0 plus 1, so that will be a 1. The third part, c times 0, so the third part is 0. So it's going to be just b equal to 3. So we get one unknown solved. And then we will substitute n equal to negative 1 here. So that will get rid of the b. So let's substitute n equal to negative 1. So 3 equal to, the first term with the a gets cancelled out because it's n plus 1. So negative 1 plus 1 will make the a term 0. And then b term will also be 0. Then n equal to negative 1. So it is 1 times c. So it is just c. So c equal to 3 as well. Then we have to substitute any value for n. So n, let's assume n equal to just positive 1. As we know, a, b and c, the only unknown is a here. So 3 equal to, we are plugging in n equal to 1. So a times 1 plus 1, which is a 2, plus b times 1 plus 1, which is a 2, and then c times 1. So we have a plus 2a plus 2b plus c equal to 3. In this we have to plug in the values of b and c. So it is 2a, so 2a plus 2b, 2 times 3, that will be equal to 6. Then c times 1, so c equal to 3. So we get 2a plus 9 equal to 3, or 2a equal to negative 6, or a equal to negative 3. So we've got all the values of a, b and c. So we get back to this step 1 where we have written as partial fraction. So n square plus n cube, which was written as 3 over a over n, b over n square. So b over n square plus a over n plus c over n plus 1. As we got a, b and c, I wrote b and a switched because b value is positive, a value is negative. Doesn't matter which way you write. So a equal to b equal to 3. So that's 3 over n square, and a equal to negative 3 over n, plus c equal to 3 over n plus 1. We will apply the integral test to decide whether the series is convergent or divergent. So we will consider the relating function f of x. which is just n replaced by x, which is x square plus x cube. So by resolving this into partial fractions, we will get this as 3 over x square minus 3 over x plus 3 over x plus 1. Now we are going to consider integral 1 through infinity fx dx, improper integral, which is integral which can be written as, because f of x has 3 common factor, so which can be written as 3 times limit t approaching infinity, this being improper integral, that's the way we need to do, integral 1 to t, as I have pulled out 3 already, so it's 1 over x square minus 1 over x plus 1 over x plus 1 dx. So it will be 3 times limit t approaching infinity. Integral 1 over x square, when you integrate that, you can write that as x to the power negative 2. When you integrate that, it will become x to the power negative 1 over negative 1. So that will be negative 1 over x. And then integral of 1 over x will be ln x. But it's ln of absolute x, but as we are doing from 1 through infinity, we can write that to be just ln x because it's positive in that interval. And plus 1 over x plus 1, which is ln of x plus 1. Then we have to evaluate that between the limits 1 and t, and then afterwards we are going to allow t to approach infinity. So this will become 3 times limit as t approaching infinity, and then we are applying the upper limit, so that will be negative 1 over t minus ln t plus ln of t plus 1 for the upper limit. Then we are going to do the lower limit, so then subtract lower limit, so it is negative 1, then minus ln 1, which is anyway 0, then plus ln of 2, everything within the parentheses. So we can close the bracket there. So it is 3 limit as t approaching infinity. We notice here ln 1 is 0. So if you simplify, if I combine these two, we can apply the quotient rule. So ln of u minus ln v, that will be ln of u over v. So here I can write negative 1 over t. Then I can combine these two terms and apply the logarithmic quotient rule, which will give me ln of t plus 1 over t. Then you distribute the minus, so it will be 1, then minus ln of 2. Now we are going to allow t to approach infinity. Also, when we do this part and allow t to approach infinity, so if you consider t plus 1 over t, it can be written as 1 plus 1 over t. So t over t is 1 over t. So when we allow t to approach infinity, the second part 1 over t is going to become 0. So it will be just ln of 1. So allowing t to approach infinity, we are going to have 1 over infinity, that will be 0. This part ln of t plus 1 over t, you notice here ln of t plus 1 over t becomes ln of 1 plus t, and then 1 plus 1 over t becomes 0 as t approaches infinity. So this whole thing will become just ln 1, then plus 1 minus ln 2, which is a constant. Ln 1 is anyway 0. So it is just simply 3 times 1 minus ln 2, which is a finite number. So we can say the improper integral 1 through infinity fx dx, which is equal to 3 times 1 minus ln 2, being a finite value, it is convergent. The integral is convergent. Because improper integral is convergent, this given series sigma n varying from 1 through infinity. So this is by integral test. By integral test, sigma n varying from 1 through infinity, the given series is 3 over n square plus n cube also converges.